Today we're going to learn how we use the inverse operations we learned last time to solve some basic equations that have more than one step. So let's begin. Now I want you to consider the following. I've got 2x, I'm then adding 3 and it equals 11. I've represented this statement here in my set of scales, where I've got 2 of those little x's, I'm adding 3 to the left hand side, and then on the right hand side I've got 11 of those little dots. Now in order to be able to find how many of those little green dots are in each one of those x boxes, I need to first isolate the x box on its own on the left hand side of the scale. To do that, I first need to remove those little green dots that are there. So I need to take these little green dots away, which I'm subtracting by 3 when I do that. However, if I do this, the scales aren't going to be even anymore. That means on the right hand side, I have to also subtract 3 to keep my scales balanced. So I'm going to subtract 3 of these away. So what I'm left with here is I've got 2 of these x boxes and it's balanced, so it's equaled with 8 of those green dots on the right hand side. Now of course we learned last time that if we've got 2 lots of something that equals 8, we should divide it into 2 different groups, but we have to do it on both sides. So we'll have 2 of these little x groups and we divide the remaining dots into each one of those x groups evenly. And what this visually means now, we can see that each one of these x's is going to be equal to 4 dots. So our x value should equal 4. But that's how we find it visually. What did we do algebraically? Well, there's 2 ways that we can think about this. The first way we can think about it is we started with this x value. What did we do to the x value? Well, first we multiplied the x value by 2 and it equaled 2x. Then we added 3 more to the problem, which equaled 2x plus 3. When we had 2x plus 3, we had an answer of 11. But now we've got to peel this back away, so we've just got the x on its own, it's isolated. To do that, we've got to do the inverse of what we did, or the opposite of what we did, in the opposite order. So the last thing we did was added 3. So the opposite of that is subtracting 3. Now 11 subtract 3 is going to be equal to 8. So we can see that 2x will equal to 8, which we had that before. Then the first thing we did was multiply by 2. Now the inverse of that is to divide by 2. So 8 divided by 2 is equal to 4. So our x value is going to be equal to 4. So what we can see here is we can use this flow chart that I created to be able to find the value of x. But how do we do it just using algebra? Not using a scale and not using a flow chart. Well, let's take our original problem of 2x plus 3 equals 11. And let's consider on the left hand side, what order would you normally do this in? Well, I'd normally go 2 times x first, then I'd add 3. Now, I'm trying to isolate the x on its own. So what it means is I have to do the complete opposite. So I need to remove the plus 3 because it's the last thing I did. How do I remove it? I perform the inverse. So I subtract 3 from this left hand side. But whatever I do the left hand side, I must do the right hand side. So I subtract 3 here as well. You can see that plus 3 subtract 3 will cancel. And on the left hand side, I've just got my 2x. And that's going to be equal to 11 take 3, which is equal to 8. So now I'm left with the 2 times x. To remove that, I must perform the inverse of multiplication, which is division. So if I divide this by 2, that will cancel out. But whatever I do to one side of the equation, I must do to the other side. So I must also divide the right hand side by 2. So on the left hand side, I'm left with just my x, and that will equal my right hand side of 8 divided by 2, which is 4. Therefore, my x equals 4. But the good thing about these is we can always check to make sure we're right. So let's perform a little check step in here. To form a check set, we've got to substitute our value that we think x equals into the original equation and see if it balances. So our original equation was 2 times our x of 4 plus our 3, which equaled 11. Now 2 times 4 is 8 plus 3 equals 11. Now 8 plus 3 does equal 11, so what we've found here is a correct true statement. That means x must equal 4. But let's take a look at a new problem. What if we had 7 subtract 3x and that equaled 22? Well, let's start in our flowchart again. Let's start with our x value. What's the first thing that we do to our x value? We actually multiply it by -3. And be very careful here. We multiply by -3. So from this step, we're multiplying by -3. And that equals -3 lots of our x value. Then after that, we're actually adding 7 to it because this is a positive 7. So from here, we're adding 7. Now we could write this as -3x plus 7, but I'm going to represent it as it was in the problem, which was 7 subtract 3x. At this point, we knew that it equaled 22. So to find out what x equals, we've got to isolate it and do the complete inverse. Now, the last thing we would normally do is add 7. So the first thing we have to get rid of is that plus 7. We do that by subtracting 7, which is the inverse of addition. Now 22 subtract 7 is equal to 15. So what we've found is -3x is equal to 15. But of course, I don't want to know what -3 times x is, I want to know what x is. So we need to perform one last inverse operation. Now in the original step, we multiplied by -3. The inverse of multiplication is division. So we here need to divide by -3. Now when we have a positive divided by a negative, our answer is going to be negative. And we've got 15 divided by 3, which is 5. So we're proposing that x should equal -5. But of course, let's try and do this algebraically without using that flowchart. So the first thing that I would normally do on this side is multiplication, so the -3 times x. Then I would add 7. So it's that plus 7 there that I need to remove. Now the inverse of addition is subtraction, so I need to subtract 7 from this side to remove it. But whatever I do to one side of the equation, I must do to the other side. So I've got to subtract 7 here. On the left hand side, these two statements will cancel and I'm left with -3x, which is equal to 22 subtract 7 or 15. Now I would normally go -3 times x. So the inverse of that is to divide by -3. So if I divide this side by -3, these two will cancel out and just leave my x on its own. But whatever I do to one side, I must do to the other. So on the left hand side, I've isolated my x value. On the right hand side, I've got 15 divided by -3, which is -5. Therefore my x must be equal to -5. Now of course, we can check our solution by using substitution. So let's do that now. Our original statement had 7 subtract 3 times x. Our x value is -5, and that equaled 22. Now, -3 times -5, a negative times a negative is going to be a positive. So we've got 7 plus 3 times 5, which is 15, and that should equal 22. 7 plus 15 does equal 22, so therefore we've found ourselves the correct solution, which is x is equal to -5. Now, where we're leading to this is we actually don't need to draw this flowchart to be able to find the solution. We can find it using algebraic methods. So now it's your turn. I'd like for you to have a go at solving these problems yourself. Now I'd like for you to try and get to the algebraic method of solving these problems, but that flowchart might help you to begin with.